it would be very cool if the head runs around the tail, so the tail never moves, but the head is always run around the tail. So, good morning. We are the guys from Germany. Hello, Achim. Hello, Frank.
Hello, Thomas. Hello, Achim.
Hello, Thomas. Hello, Frank.
Are you well prepared for the day 9?
Yes, of course. The previous days we had some difficulties with text understanding, so today we will focus more on understanding the text and then implement it.
Sounds good. So, 3 minutes left. So, 5 seconds left. 4, 3, 2, 1, go.
Yo, bridge, rope bridge.
So, this rope bridge creaks as you walk along it. You aren't sure how old it is or whether it can even support your weight. Figure out where not to step.
Head and tail must always be touching. What does this mean?
They need to be in contact.
I think your hand should be always on a rope. You go over the bridge. Maybe it's a swinging bridge or something else, and you have to hold every time.
Yeah, we got a 2-dimensional grid, and we got a head and a tail marked with an H and a T. So now the head is moving around somehow, and we need to determine how the tail is moving. Now I ask, this rope has a given length, like a rope has. Now, how does this work together? Why do the head and the tail must be touching? I don't understand this. If the head is ever...
So, if the head is ever 2 steps directly up, down, left or right from the tail?
The tail goes after the head, like we got in this line here. If the head moves one right and the tail is left of it, then the tail moves also to this right. Okay, so if the head moves like left, then they are in the same position, again left, then the tail is right of the head, and then left, then the tail would also go left. That's it. So the rope has always a length of 1.
Is this like a rope
It's a rope.
No,
Yes,
no,
yes.
it's like a worm which is moving.
Rope ist ein Seil auf Deutsch.
Yeah, I know this. Sorry.
Okay.
It's like a moving worm. If a worm is moving, he goes up and down and up and down.
Let's stick with the word rope.
Okay, it's a rope.
It's a rope.
And the rope has a fixed length.
Yeah. So, and this means it goes right 4 positions, yeah? Right 4 steps, then up 4 steps, and so on. And then the final question is, how many positions does the tail of the rope visit at least once? Okay, we have to find the visited locations of the tail of the rope. So now we have to simulate the movement of the head, and from this the movement of the tail. And from the movement of the tail we can more or less simply find all visited locations. Yeah? So how do we organize our grid? So fixed size thing would be okay, I guess. We just need to make it big enough. I will download the input to have a impression on how big this input is, how many steps we go. So I downloaded it.
I got 19 in my riddle.
90 what?
90 R. What was R? Right. Right to the 9. Right 90. Down 90. I think if you're working with a constant array or
So
something
it's 2,000 lines and it's always 2-digit numbers. So the whole thing does not move more than, say, 20,000 positions. So this is a lot. Too much for, no, it's not too much. It's okay. So line A. So this is,
S is the start point.
so first I do some data structures. So
Yeah.
this is a two-dimensional array to mark the visited locations. Yeah. So n times n in size, 20,000. I start with this. If this seems to be not enough, then we will just increase it. So then let's call them X. So I put the starting point in the middle of the grid. And then we can move around here. So bring.
Okay. One point is the tail moves diagonal.
Yeah, we need to reread it how the movement works. Now let's first put the structures together and then.
I read it again.
So now each line, is it correctly with these lines? So there are no other lines than this. Okay, this looks good. Okay. Now let's look the movement again.
So after each step, you need to update the position of the tail if the step means the head is no longer adjacent to the tail.
Yeah. So it's like always the case if the head moved. So, but, oh, no. So if it, like here in this example, so if the head is right up of the tail, then it moves one up. Then the tail goes after it, like this. Okay, this is one rule.
Yes.
And if the head is after this and goes right, then it goes in. So, okay. And if it goes right up, but this does not work. It goes only in 4 directions.
Yes,
so,
head only goes in 4 directions and the tail in 8 directions. So in the first example, the head is going up.
Goes not in directions. Tail goes after the head. This is
again
misleading too.
Frank, in the first example, the head goes up.
Yeah.
And the tail is on the left side and he goes diagonal up and right.
Yeah. Yeah. But I think it's not sufficient to think about the tail moving in a direction. The tail moves after the head. So you calculate the final tail position from the head. So if the head moves one up, then the tail is one below the head. But independent of what it was before.
Is it
it's
right?
Always this. If the head goes one up, the tail is always behind the head. No matter where it was before.
And is the tail exactly on the old position of the head?
Yeah, well, except when it was next to it before, because if it's next to it before, then it's diagonal.
I think the tail is always on the old position from the head.
Nope. No, consider this example where the head moves, where they are next to each other and then moves the head one up. So like this, head is right of the tail. Now, if the head goes one down, then the tail does not move at all. The tail stays.
That's right. If head change the direction, if head change the direction, then nothing changed to the tail.
No, you are right. The tail is in the position one after the head, except for these one-step things. When the head is next to the tail, then it stays there. This is this. So there are 2 cases. So now let's just implement a bit of parser things. So bring us So now as a 0, there is this letter. So X head. So where do they start? Next to each other? Head and tail?
On the start point, yes.
Above each other.
This means tail is above or below or what?
They
Both.
are on the very same position.
Same position, on the same position.
Okay.
Genau. Assume the head and the tail both start at the same position, overlapping.
So right means example plus. Left. Summing up. X, Y. X head. X head. So up. Y head plus plus. Else if S0 equals down is the fourth direction, then Y head minus minus. Else also false because something is wrong. So, and what is the next thing is the number of steps, okay? Steps equals S too long as S1, and this is less steps. Is less steps. So now check the distance of both. And then we need to find a direction or what? Now, if the head and the tail distance after the head move is only 1, then the tail stays. And if it's more than 1, then the tail moves after the head. Okay? And dx gleich x head minus x tail. Ups. dy gleich ups. Y head minus epsilon tail. So if dx größer 1 oder der y ist größer 1. So if this is the case, move the tail after the head. So now we need to go one step back. This is nasty again. One step back or one step less. Dx. It's the previous x and the previous epsilon. So dx x head. In previous epsilon head. So these are the previous values. So this is steps minus 1.
Okay.
Now I calculate the position here, and if it needs to be used, then I move the tail to that position.
Yes. I got a little hint. Maybe you got it. If the rope goes up and down, then nothing changed to the tail.
Yeah.
This is important.
I got this.
Yes. I thought I got a quick solution. I copied everything in Excel and doing a sum, but this was not right, of course.
Y tail gleich py. So with xt y t gleich true. So, let's see what's now. More. Let's give it a try.
Oh, this were fast. 15 minutes.
Fix my data structures here. So this is a two-dimensional array of
Yes.
bits, actually. So this is null. Why my S is null? Got some. Why is this?
Split VS. Really?
Really what?
No. Oh, you got an. No. Okay. What is S?
As it's wrong here. My split function get as the first
Yes.
thing.
Okay.
So I think this is better. Do I have some endless loop somewhere?
Is this an old error exception? PX?
I don't understand.
No, the warnings on your screen are these are old one?
Oh, it's warnings.
So you declared PX twice. This is what I want to say.
I'm currently trying to understand why my program does not stop at all. It runs like endless.
You declared PX? Yes. Okay.
Yeah, it does not hurt. So why does this run endless?
Good.
Is it so slow? This can't be that slow.
No. But you split on a line break.
I will do some debug output. Yeah, I split on line breaks and things. Nothing happens at all. I got no input, isn't it? DMP clipboard input.txt b9a.test. I guess this works better. Is it?
We will see.
Nothing happens here. Oh, this is annoying. My infrastructure does not work like expected. Why is this?
Kill.
I split it on the new lines, yes?
Yes, but your system out or your C out doesn't work.
So here I should simply get the input here. There's not much that can be wrong if anything works right here.
Okay. No output.
Output. Why?
Yeah.
Why is this?
Is your solve method called?
It's killed for some reason. Why? I don't get it.
So GS is GC in. The first line under solve is GC in. Is there something? Is there an input? Can you make an C out after the GS string?
Let's try this.
So nothing happened.
Yeah, it outputs this
Okay.
thing.
It outputs. Okay.
So now it should parse it to lines, but it does not for some reason.
and you got an empty line at the end. Is it okay? But it should not.
Wouldn't care for that.
So, and then what is VVB? VVB this. What doing this?
This defines an array. It's just a declaration.
Okay.
It does nothing. So the next thing is what happens is I split the whole input into lines. So with this function here. This should actually work.
Yeah, but it does not work.
Yeah, but it should. Why doesn't it work? I use this on every other day also.
Okay. If you move your first input directly before the for loop.
So this is trial and error. Let's try to understand why it does not work. So I can try 1,000 things, but this does not lead to a solution. We need to understand why I'm doing something wrong here. If you spot something which you think is actually wrong, then please tell me.
We have to take a look into your methods. Split, VS, stole, and...
yeah, I used them the last 10 days, and they always worked. I tested them for hours. Come on, Thomas. It's a trial and error if you think these methods will be wrong here. So this is what I mean. If I say, if you see something which is wrong, then tell me. If you think somewhere else should be something wrong, then that's trial and error. So, but we can do it maybe like this, or as one. So now we got this loop separated from the parsing and can maybe see something here. But of course, you are maybe right. Something with the split function is wrong. So,
and you should remove the first cout for have lesser output.
Doesn't hurt.
Yeah, that's right.
I'm clicking Control C here to abort it, but I did too often. Maybe.
Why you split? Can you go to the code again?
I try. My console just is a bit slow here.
What is GS? Is GS the whole file or is
it's a global input, global string, so the whole input is GS.
And
here we output the whole input.
Okay, and split doing this in rows that you get rows?
Yeah, it splits by this substring here. It searches for line ends and then splits it at line ends.
Okay.
So I just want to try one thing, which is
it
maybe it has to do with this last line or something like this.
Yeah. Is it possible that other line endings are used?
Nope.
Okay.
It's annoying. I now have a quick look in yesterday's solution. So here we got the same string GS, GCin. I always use this.
And you split them.
And here I split it by white space. Maybe I simply change this code to also do this. Fine. So we can split VS. This doesn't work. So now I have to iterate otherwise for int 0 slash
okay, with this method you split for white spaces, so you got for every line 2
so now I got the same.
Yeah.
Was it this?
And you can concatenate.
Let's try this. Still seems to not work for some reason. get it.
So the line break is the problem? Okay.
No, I
what-
even don't get this
Okay.
output as 1.size. So this input, for some reason, is not splittable into white space with my methods.
I know you don't like it, but can you move the first output directly?
This one?
Yeah, move it directly above your split.
Here?
Yeah, nothing should change, but maybe it depends on your array declaration.
Yeah, okay. Let also put something in here in the split VS function.
What is
Endl is line of end line.
now in your code? So no output. Okay, then it depends on your array declaration.
No, wait some seconds.
Okay. 1, 2, 3, 4, 5, 6, 7.
Maybe.
So let's go to your array declaration and tell me what is n, please.
N.
Yeah.
N,
Yes.
N.
Yes. You declared an array.
2e5. So 2e4 must this be 20,000, not 200,000.
Okay.
An array 200,000 by 200,000 is simply too big. What a bad thing.
What should I say? I say nothing else since minutes.
No, you didn't mention that. You mentioned that my parser is wrong. It had
No.
nothing to do with the parser.
I'm talking about the array. And my first assumption was doing the cout a little bit down
Yeah, okay.
after the declaration. And you say, no, this is try and error. Yeah?
So now my starting index is not good also. So we start at 100,000, but we need to start at 10,000. So 1e4. Yeah, but technically not the declaration was wrong. The size was wrong. So this is actually another error.
Yes, this is in detail. I don't know.
Yeah, but this detail was wrong. This detail was the reason that it does not work.
Yes, and
So now let's try this answer
Yeah.
here. And it's also wrong. So maybe the start position should also be marked.
you have maybe you have to -1 because on the first position there are tail and head on the same position. Have you?
Yeah, I need to mark the first position. This is X tail, epsilon tail, gleich true. So now it should be one more than before.
Okay.
Let's check this. So it's now 1532, then this was the error. Yeah, it's 1532, not 31.
Okay, I thought one less.
Eh.
Why,
11 seconds, wait.
But why one more and not one less?
The starting position, I didn't mark the starting position as visited. So now I marked it. Because I marked it now, it's one more.
Yeah.
Yeah. And it's not the right answer. So the partial bug was solved, but this did not give the right answer. So now we need to think about why it does not work, because technically it looks like it would work. And also the number looks more or less reasonable, 1,500. So I guess the movement of the tail is not correct. It's just a guess, but this is the part of the thing, and maybe so we can try the real input, the test input.
I see something strange.
Okay, so we are in trial and error mode again. Let's try this example here. Maybe we see it directly.
Yeah. And maybe this is okay in your code, but for me it looks strange. You got one time size -1 in your if conditions.
So what should be the right solution here? 7?
30.
13 position. So something is wrong here.
Yeah.
But so you see an off by 1 error here?
Now, no,
somewhere?
in the first if condition,
The first if condition.
doing steps.
Which one is it?
Steps, also steps -1 for the R. What is -1 and why?
So if the head moves
Yeah.
10 steps in some direction,
Yeah.
the tail has to move 1 step less than the head. So the position where the tail ends is the head position, but 1 step less stepped like the
Okay.
head.
And
So-
why this only happens for right and not for left and not for up and not for down?
Right, that's it. That's a good point. So now it does.
Yeah.
And now I got the other input. Should give 13, but gives 5. There's something wrong with this. So, but the tail, it's look, if it moves 4 positions, then it's not that it's only the first and the last. It's all in between. Also, we can't do it like this. So we need to mark all visited between those both.
Yes.
So okay. Now let's do. How do we do this? Okay, now we need to move the tail of. Now, how does the tail move in these cases? So the tail is always in distance of 1. So say it's next to it, then it moves in one direction. It moves down, then it moves left and down, or how does it move? It always moves after the head. So we actually need to trace the head movement.
And you have to know what was the movement before.
Yeah. Well, the 2 other variables.
Okay, my test run for part 1 works.
That's nice.
Wow, I got a star.
Nice.
When the tail moves after the head, it seems that the positions directly north, south, east, and west of the head are preferred to the diagonal positions.
Yeah, the tail
I
moves the
distinguish
same
between them,
positions
so-
the head moved. So when the head moves and the tail also moves, then the tail moves first in the position where the head was before and then after it.
Yes, but the tail seems to when the tail moves, it seems to prefer the positions
You can phrase it like this. It's kind of the same.
on the cross and not the diagonals. To put longer ropes. How do I do this?
This is wrong. Up is B.
Achim,
Yes.
what happens if the head goes to the tail? So if they are touched together again.
They're on the same position and the tail is happy.
But the tail not moved.
The tail doesn't need to move in that case.
Yeah. Okay.
Closer, but not actually close. Maybe I still did not really understood the movement of the head and the tail.
I simulated manually with an Excel list where the tail is and where the head is.
Okay.
And it's interesting, the tail only moves if the head is one distance away. And then the tail has the old position of the head. So if the head is down and the head is up, and the head moves right and left and right and left, the tail does not move because it's only nearby to
the
near.
tail only moves if the position of the head is more than one.
Yes, exactly. And then the tail is on the old position from the head.
Yeah, exactly. And that's what I implemented here, but it does not work. So here's something wrong still. Yeah.
Maybe you can implement a little coordinate system to have coordinates X and Y, and then you can play with X and Y. And
I did exactly that.
Oh, okay. Sorry, I was off for.
Now I got my coordinates here.
Okay. Mm-hmm. Yes. Yes.
And all I'm doing here is I check the distance on the X axis and on the epsilon axis, and if one of them is bigger than 1,
right,
then there's movement of the tail. Else there's no movement of the tail.
Right.
So now I check the previous position. This is the previous position of the head, and I mark the previous position of the head as visited, and then I go steps -1 because I go after the head. So this is, say, the first step, and then steps -1, and this should actually work for some reason, but it does not.
I do not understand why this line where you are currently there is exactly the same. Oh, no, my problem. Sorry.
So the position of the tail is X tail and epsilon tail. And I increment this by the direction. So here's the direction. So this is left and right and down and up.
But
so I don't see what could be wrong here. This looks correct. This KX thing, do I use this somewhere?
In your for loop, this is about the steps.
I actually don't use this here. PX PY. PX PY. Just make the code a bit simpler.
Yeah.
To spot the error. Same output. I actually don't use these ones.
Why you go step -1 in the for loop with the K in your if condition?
So the first step the tail does is say this: if the tail moves at all, it does in all the same number of steps as the head does, because it also follows the head. So the first step is that it steps in the old position of the head, and then it does steps -1 further steps.
But you do this every time, right?
Yeah.
No,
every time.
Every time the tail is on the old position from the head?
It starts on the old position from the head and then goes steps -1 steps in the same direction as the head. So it follows the head.
Okay. You are only in this condition if you are more than 1 away.
Yeah, this is this one. Move the tail after the head.
Okay.
Only if.
Yeah. Okay. Understand. And then you are right. The tail is on the old position from the head. Correct.
Yeah, this is it.
But
let's check this twice if this is really correct. So what is X head and epsilon head?
What is? How do you count? Do you count the truth?
first I marked them as visited. So
Yes.
xt, yt is true.
Yes.
So I got a 2-dimensional array with a lot of positions.
Yeah.
And then in the end, I simply count all marked visited.
Yes, but if there are again on this field, it's marked.
Then it's still true.
Yes.
It's set to true. If it's set 3 times to true, it's still true.
Yeah.
So
Which
in
is
the
totally
end,
fine.
I count how much.
Yes. Okay. This is okay. Just, okay.
I can set them to
Yeah.
1.
No.
Maybe
It's right. Everything is good.
Yeah, it's the same.
No. Yeah. Okay.
So,
no.
but still, there's something wrong. So we can output this thing in the example. Maybe this helps if we output these marked fields. So let's do it like this.
By the way, for the honor of the company, I have already completed.
Congratulations, Achim.
Very nice.
Congratulations. I think I disturb Frank too often.
I don't think so.
Today it's feeling like a Muppet show.
So let's look at this. Maybe this helps. Okay. What is this?
Oh.
It's smaller than n. I need to do this. Okay. So here it's 1, 2, 3, 6 by 5. I can use these numbers here because it's only the bug output.
Okay.
Okay, they are all marked.
Every
Why
position
they
is
are
marked.
all
Wow.
That's not right.
Thank you, Achim, for this comment.
Yeah,
I know,
but I
very
guess
useful.
my output here is also wrong. This is I start at 10,000 and something, but why is this? Okay, it's just that I did it so. I have to start at 10,000 and then 10,005, something like this.
Attention,
My grid
attention,
is
attention,
not-
attention. You got a 0 too much.
100,006 for the y coordinate.
Okay.
So it looks better.
Why is there an S here in the left down corner?
That is the starting position. It's marked differently.
Okay.
So to not confuse, but it has to be counted in as you're right and that.
So you go.
Okay, my coordinates here are also swapped, but it does not look like
You got a very, very big rope. That's because you have right and left every time.
Yeah, but something with the movement is wrong here.
Yeah.
This is
Okay. So right is 1, L is 0, up is 3, and down is 2.
so does it matter the direction? So if we swap right and left, for example, it does not make any difference. And also if we swap up and down, it does not make a difference. So up and down must be opposite directions, but this is okay. So it does not matter if I got up or left for the x-axis or the epsilon axis. So this can't be the error.
It's just a 90% transformation.
Degree in this case.
90 degree, yes. Percent? Yeah,
But
degree.
maybe it's 90% correct.
yeah, 90 degree, yes.
So,
Um,
okay, what could be wrong here?
so
Let's phrase it like this.
xh plus, xh minus, yh plus, yh minus. This looks...
Maybe if this is
You don't move. You don't do in every step singular. Maybe that is a problem. You just jump ahead and steps.
I do not. So here this loop with the case here. This is exactly number of steps. And I do every step. This DDX is always one position moved. So I move field by field.
No, a bit up in there where you discern by directions.
Yeah.
There you are modifying XH and YH.
Yeah, it's the head position. And the head position actually jumps.
My solution, my header does single steps and then I check for the tail's position.
Yeah, okay. This
one by one.
Necessary. So I could also
Maybe
increment the header down here in this loop. This would be basically the same. So I just need to make sure that these increments to the tail are the same as these increments, but this should be X tail, DDX steer, X header plus steps. And the direction, maybe this would be wrong. So let's do it like this.
I don't understand why
it's difficult. Why what?
Why the for loop is only in the if condition.
Because if the tail is not moved at all, then it does not move. So this above here is the head movement. And this below here in the if condition is the tail movement. The head movement always happens here.
But
let's make sure that is correctly here plus and here minus. How can we be sure about that? So X header plus steps is if we go right, and right is actually deer 1. This is the same. So if this is tail is plus DDX deer, so if deer is 1, then it's added, and if it's 0, then it's subtracted. And this is actually right here on the X direction. And in the epsilon direction, it's up.
Then up and
3, so it's incremented, and here it's decremented. So this is correct.
But are you sure that up and down is correct? Also, if you're on the screen, you were wrong. You more.
Yeah.
Ne?
So it's correct if the tail and the head move in the same direction, and that I just checked this one. So here for up the head increments. So up is more, and also the direction is 3. So 3 is the positive one here, and 2 is the negative. 1 is 0, and 0 is 0.
Okay.
So this is correct, or seems to be correct. So should we output this grid after each step? Maybe that helps.
Now I see the point. H covers T on S.
Exactly.
Yeah.
The tail, if you think in 3 dimensions, the tail can hang directly below the head.
Yeah. The last one of the last examples has it again. Should we break up at 7 o'clock for the video? As not for your solution, but maybe for the video.
Just decide by yourself.
I'm not sure. So 1 hour is very long.
My motivation goes kind of down.
Yeah, I understand.
I don't want to debug this stream processing thing here.
So let's take a look at the solution from Achim. Can you share your screen, please?
I already did, but it somehow got lost. Whatever. Okay, my solution for day 9. Only standard Java classes as always, except for the IO util, but that's nothing new. So we are on a rope bridge, and there are ropes with the head and the tail on the plank, and that stuff is moving around like crazy. So the head moves around, and the tail needs to keep up, and the rope is 1 unit of rope long.
Okay, and you starting tail position is equal to head position. Okay.
Exactly. And as yesterday, I'm using a single integer to describe a position.
Yeah.
Because the positions may go away up to 1,000 units from the starting point. Set the starting point at 1,000, so that both components remain positive. That's important for adding them up, because if you don't do that, if you later try to figure them out, it gets a bit haywire.
Okay.
And as I get so big on the components, the separating factor is 10,000.
Okay, and then
10,000.
You got your input, and you getting a direction in line 43.
Exactly. I pass through every entry. The first character is the direction, and that is followed by the number of steps we need to take.
And you iterate over the steps.
And I take 1 step at a time.
Yeah.
If one would want to accelerate this, it would probably be useful to tear this switch out of the for loop, but it's fast enough, so I didn't bother on that.
So you switching the head position. What I don't understand is your factor for left and right.
This is -1 +1 on the y-axis, which has a factor of 1.
Yeah.
And this is plus and -1 on the x-axis, and that is multiplied with a factor.
Okay, because then you get a big integer where x and y is included as a...
Yes.
Okay.
This is a complete position in a single integer.
Okay. Very interesting.
So, and then I check if the tail is still in touch with the head position.
Yeah.
And for that, I'm making this a little bit bigger.
Yeah, no problem. We know the solution.
I have a set of integers of all fields around the head, including the head position itself and all its variations.
Yeah. This is a little bit hard to read. It depends on your factor, but I think everybody understands it. You check
essentially
around
the left, the right, the top, the down, and the 4 diagonal positions. And when I ran it the first time, I forgot the diagonal positions, and the solution was completely off.
Okay.
And I only need to do a contain, and then I know if I'm still in touch or not.
Yeah. Okay, so
if I'm not in touch,
you have to move the tail.
I calculate the new tail position.
Mm-hmm.
Again with the head position and the tail position. And there I have the set around tail, which are all the positions around the tail that the tail could move to, because at this point we know that the tail needs to move, so the tail position itself is not included.
Yeah.
And we have 2 sets of positions around the head. The first one is the head position itself, and the positions to the north, south, east, and west, because these are somewhat preferred towards over the diagonal positions, which are in around head too. So, having these 3 sets, I reduce the around head sets to the intersection with around tail. And if around head 1 is empty, and only then I take the result from around head 2, the diagonal positions.
Yeah.
But if it isn't empty, I use one of the straight positions
Okay, understand.
where I move the tail to.
So
So moving the head and the tail one step at a time.
okay, and what was the biggest challenge for this riddle for you?
Figuring out how the tail moves and getting my coordinate system right, because initially I had starting position 0 and the coordinates got all messed up.
Yeah, it would be very cool if the head runs around the tail, so the tail never moves, but the head is always run around the tail.
In part 2, that actually happens.
Yeah.
You can see my output down here. That is a test output from part 1. That is my actual result. And that is the output for the original test data set with part 2.
Oh.
And there's a second example given, and I used that as well. And it worked, and I got to the result. The difference in part 2...
Oh, can you show us the second riddle? Because...
Yes, I can. For the second part, the rope gets a lot longer.
Okay.
It now has a length of 10.
10.
And this is for the first example, and it states here that the tail element moves only visits one position because it never leaves this point.
There's no need to move the tail because the tail is too long. Mm-hmm.
Exactly.
Okay, understand.
And so they give a second example, and I used that as well because I got the one, I got that, and is that right? Oh, another test data set. Let's look at that. And if it moves around here, you see here's a tail.
Yeah, a very good example.
And it moves somewhat like a snake.
Yeah.
And what it essentially is that H is one is the tail of H, 2 is the tail of 1, 3 is the tail of 2, and so on.
Mm-hmm.
And that is how this can be solved. And that is what I actually did. So I don't have a scalar value for the head and the tail positions, but I have an array containing 10 positions with position 0 being the head and positions 9 being the tail element that is relevant for the solution. The remainder is essentially the same, initializing the starting position, go through all this, and doing the in-touch check on through all the tail elements.
Okay.
And if the last element actually moves, doing an add.
Understand. How long do you need for this riddle?
Let me look that up. Leaderboard, personal stats. Part 1, 36 minutes, and part 2, another 10.
Yeah, congratulations. Okay. Achim, thank you. So, everybody, today we not solved, Frank was not solving the riddle in 1 hour. Congratulations to Achim, you solved it. And that's all for this video. And we see us tomorrow again, and I hope we got more success tomorrow. So bye everybody, and thank you, Frank. Thank you, Achim.
Have a good time.
Bye.